Hello everyone. This video we are learning 4.3 graphs of tangent and cotangent function. First, let's see vertical asymptotes. In algebra, we learned vertical asymptotes. They are vertical lines. And my graph is getting close to it from the left or from the right. Or we have vertical asymptotes. My graph is getting close to it from the left to right this way. For the tangent and cotangent, we all have the vertical asymptotes. So the graph between two vertical asymptotes, so between these two vertical lines, this is one full cycle of tangent x. And tangent is an odd function. When we input negative x is equal to negative tangent x. Domain of the function, all the x value is x is not equal to the vertical asymptotes. You can tell from the graph. So vertical asymptotes here, x value, they are all equal to the odd number times pi over 2. Ranges from negative infinity to infinity because all the way going up, all the way going down. Okay, period. Between the two adjacent vertical asymptotes, we have one full cycle. So for this one full cycle, the x value, for example, is from negative half pi to half pi. So the period is pi. The x value, the x between negative pi over 2 to pi over 2 is pi. And vertical asymptotes is 2 times n plus 1 times pi over 2. And when the x approaches pi over 2 from the left, so this symbol means from the left, we can come to the graph and see where is the x approaches pi over 2. Okay, x is equal to pi over 2 from the left. It's on the left of the vertical asymptotes. Y's value approaches negative infinity. And when the x approaches pi over 2 from the right, the y's value is here, approaches negative infinity. And for the tangent, the most important thing is a table. Let's have the table of tangent. This x, this is y's value, tangent x. We need to have 5 key points, like we are solving the question from the sine and cosine. The first key points and the last key points, so not the key points, x key numbers, they are the bound of one full cycle. So I'm going to select negative half pi and half pi. Between them, they are one full cycle of the tangent. So let's put negative half pi and then half pi. In the middle, we need to have 3 other x values. So we can divide one full cycle into 4 equal parts. Okay, so from negative half pi to half pi and cut it into 5 equal parts. So the x value is negative pi over 4, 0, and pi over 4. The y's value, so negative half pi and half pi, they are vertical asymptotes. And for the negative pi over 4, so tangent's value is negative 1. And then for 0, tangent 0 is 0. Tangent pi over 4 is 1. So let's memorize this table. For the cotangent is also an odd function. When we input negative x in the cotangent, it is negative cotangent. Domain is x is not equal to n pi. Okay, so n is equal to 0 is this vertical line. N is equal to 1, so x is equal to pi. So it is integer n times pi. Between 0 and pi, this is one full cycle of cotangent. Ranges from negative infinity to infinity. Period is pi because between these two vertical asymptotes, this is one full cycle. Period is pi. vertical asymptotes is x is equal to n pi. And cotangent is equal to 1 over tangent. Cotangent also equals cosine x over sine x. And cotangent negative x is equal to negative cotangent x. It is the reflection across the x-axis of cotangent x. Yes, because in front we have negative sign. That means the reflection along the x-axis. Okay, if I'm going to graph this function. Let's clear this. I'm going to graph this function. I'm going to have increasing function. And the 1 full cycle is from 0 to pi. Okay, let's do a conclusion. Find the 5 key information for 1 full cycle. Okay, we can draw a table. And this table is the 5 key information, or I cannot say 5 key points, because the first and the end, they are not points, they are vertical asymptotes. We can say the important information in 1 full cycle, x and cotangent x. And the first is the initial vertical asymptotes. This is 0. And last one for 1 full cycle is pi. And between them, we need to have 3 key points. This is 0, this is pi. We cut it into 5 equal parts. This is half pi. Now this is pi over 4. This is 3 pi over 4. Okay, pi over 4, half pi, 3 pi over 4. And vertical asymptotes here. 1, 0, negative 1. So let's memorize this table. Here is a conclusion of the cotangent and tangent. I'm not repeat this part. And they are all the functions. So how about finding the period of the tangent and cotangent function? For the sine and cosine, let's review a little bit. If I have cosine bx plus d, for example, and the period is equal to 2 pi over b. And now if I replace the cosine by another function, is tangent and cotangent. Let's put it here. If I have tangent, put the a in front, times bx plus d, then the period of the function is equal to pi over b. It is not 2 pi, it is pi over b. Okay, let's see the example 1. We have a function y is equal to tangent kx, and find the value of k. Okay, from the graph, can you tell me where are the 2 vertical asymptotes, or find more vertical asymptotes? So vertical asymptotes is here between 2 vertical asymptotes. It is 1 full cycle of the function tangent or cotangent. Okay, so between these 2 vertical asymptotes, it is 1 full cycle. Also, I can tell the period from -2 to 2. The period is 4. Okay, so if period is 4, also I have learned the formula finding the period of tangent. It is pi over b. Now the b is k. So it is pi over k. So k is equal to pi over 4. Okay, I found the value k. So the function is tangent pi over 4k. Pi over 4x. Okay, how to graph a function? If the function is very easy, I know how to graph it. For example, if I have 2 times cotangent x, I know this 2 means vertical stretching. So if the mother function, for example, cotangent is a decreasing function from 0 to pi, and if I stretch vertically, that means I'm going to have my function skinnier than before. And then we stretch the vertically. And based on the parent function, for example, this is a parent function. and the x didn't change. All the y stretched. Here becomes 2, here becomes -2. Okay, if I have some simple transformations, for example, 2 times cotangent x, I just stretch vertically. So the key information, for example, before here is 0, now is 0, and then go up 2 times and go down 2 times to find the key number, second and third key number. All right, how about my function is very complex. It's not just one transformation. We have more transformations. So first I'm going to find the period. So by using the formula pi over b. And then we need to find the 5 key information. 5 key x values. So we can put the bx minus c between one full cycle of tangent. And I remember that for tangent, one full cycle is from negative pi over 2 to pi over 2. Now let's put the bx minus c between negative pi over 2 to pi over 2. And how about the cotangent? Cotangent bx plus c. Let's put the bx plus c between 0 and pi, because I have learned for the cotangent, one full cycle is from 0 to pi. That's the reason we put the bx minus c between 0 and the pi. And then we need to solve for the x. After finding the x value, this is a new one full cycle of the function. We can have the initial and terminal, or we can find the first x value is mapping to the vertical asymptotes. Second x, the last one is mapping to the vertical asymptotes, and in the middle I can find the 3 key points. Okay, so step 2, sketch the vertical asymptotes. Number 3, divide the interval formed by the vertical asymptotes into 4 equal parts. Yes, so if I found the two vertical asymptotes, so between the 2 vertical asymptotes, we need to find another 3 points. So this points, so the 1/4 is the initial point plus 1/4 of times period. And then based on the second key points plus 1/4 of the period, then keep adding 1/4 of the period, we can find the key points. Then we can find y's value by the transformation, and then plot the points, use smooth curve, connect them. Okay, let's see next example. This one is very easy. If you don't want to use the 5 steps, maybe we can just use very easy steps. For example, I know what is the graph of function tangent. So this is a tangent function from negative pi over 2 to pi over 2. What is the transformation here? 2 times x. Horizontal shrinking. Even we have 2 times x, but x is opposite. It is stretching vertically. If this is the multiple choice, we just say find the new vertical asymptotes and shrink my graph horizontally, so I can find my graph. If you want to use the 5 steps, we can use the 5 steps. Okay, first I also want to identify, do we have some other transformation except the horizontal shrinking? No. So vertically we have no transformations. So first I want to bounce the 2x between negative half pi and half pi, because for the tangent, one full cycle is bounced between negative half pi and half pi. Solve for the x. So x is between negative pi over 4 and positive pi over 4. Now we can make a table. So this table, we can have 5 key information. Y is equal to tangent 2x, 2 times x. Okay. The negative pi over 4 here is the vertical asymptotes, and positive pi over 4 is also my vertical asymptotes. In the middle, I need to find the 3 key points. So the second key points is, so we know the first and last vertical asymptotes. So cut it into 4 equal parts. So based on the first one, plus 1/4 of the time period. So what is the period? Do we know? Yes, the period is P is equal to pi over B. B is 2. P is equal to pi over 2. How about 1/4 times P? Is pi over 2 times 1/4 is pi over 8. So based on the negative pi over 4, that's plus pi over 8. It is negative pi over 8. And then based on the negative pi over 8 plus pi over 8, 0, plus pi over 8. Pi over 8 plus pi over 8, pi over 4. Okay, we found all of the x value. How about the y's value? I mentioned that there's no transformation based on the y, vertically shrinking, stretching, or shifting. No. So they need to have the same y's value. So y's value for the tangent. Okay, and this is vertical asymptotes. Here is -1, 0, and a positive 1. Okay, so we have a lot of informations. Vertical asymptotes, negative. Let's see, 1, 2, 3, 4, 5. Okay, this is negative pi over 4, whereas positive pi over 4 is here, pi over 4. And here is negative pi over 8. The x value is -1. And 0, 0, pi over 8 is 1. Okay, we have these key points. Let's connect them. So make sure you have smooth curve. Okay. All right, we graphed our function. If this is an easy function, we don't have to list a table because we just select one answer, or it's very easy to graph. Second one, what do we have? Inside of the input area. So we say tangent of 1/2 x. The 1/2 is the input of the function. And it is 1/2. That means the transformation is horizontal stretching, because 1/2 means we do the opposite. We are not having the half of the x. We need to double it. So all the x becomes 2 times. And what is the meaning of -3 in front of tangent? That's the first 3 means vertical stretching 3 times, all the y times 3. And the negative sign means reflecting along the x-axis. That means altogether is y times -3. All right, let's see. If this one is difficult to sketch because we have more transformations, so we can use the table. First, we need to find the starting vertical asymptotes and the ending vertical asymptotes. We can put the input 1/2 x between the 1 full cycle of tangent, -pi/2, and pi over 2. Solve for the x. X is between. So multiply by 2, everybody. -pi and pi. Okay, vertical asymptotes. -pi, positive pi. So from the image, I can decide cut it into the 4 equal parts. They are -1/2 pi, 0, and 1/2 pi. And we need our table. And so before we are looking for the table, what is the period? Period is equal to pi over b, pi over 1/2. P is equal to 2 pi. How about 1/4 times p? It is 2 pi times 1/4 is pi over 2. Okay, if I'm listing a table, I want to make a perfect graph. X and y is equal to -3 times tangent 1/2 x. So the two vertical asymptotes, they are -pi and pi. We found them from here, the inequalities. Okay, vertical asymptotes, vertical asymptotes. And -pi plus 1/4 times p is equal to -pi plus pi over 2 is -pi over 2. And then plus pi over 2 is 0, plus pi over 2 pi. That obviously here I can tell from the graph. Okay, how about the y's value? Do we have any y transformation? Yes, we did the conclusion here. All the y becomes multiplied by -3. And we learned that for the tangent function, it's an increasing function. The key points, these 3 key points, y's value, they are -1, 0, and 1. So -1 times -3, +3. 0 times -3, 0. +1 times -3 is -3. Okay, let's start to plot the point. -pi over 2, 3. And 0, 0. Pi over 2, -3. Okay. It's not very pretty. Okay. Looks better. Okay. The point goes through the point 0, 0. All right, we got our graph. Next one, graph the function y is equal to 1/2 times cotangent to 2x. Okay, we have two transformations. First, inside of the input, we have 2x. Outside, we have 1/2. So the 2x means horizontal shrinking. And 1/2 in front, that means vertical shrinking. So all the x times 1/2 and all the y's value times 1/2. Okay, let's see. What is the period? Let's see, period first. Is equal to pi over b. Okay, p is equal to pi over 2. And how about 1/4 times p? 1/4 times pi over 2 is pi over 8. Okay, let's find the two vertical asymptotes. 2x is bounced between. All right, let me ask you. This is cotangent. What is the mother function? It's a decreasing function from 0 to pi. That means 2x bounced between 0 and pi. Let's solve for the x. So the x is between 0 and half pi. Okay, so if I'm graphing, I'm finding my table, x and y is equal to 1/2 times cotangent 2x. So I can find the two vertical asymptotes. They are 0, half pi, vertical asymptotes. And the 3 key points between the two vertical asymptotes. So based on the first x value, plus 1/4 times period is pi over 8. Okay, pi over 8. Plus pi over 8, pi over 4. Plus pi over 8, 3 pi over 8. Plus pi over 8 is 4 pi over 8, which is half pi. And what is y's value? We have the y transformation. It is all of the y times 1/2. And do you still remember the table of cotangent? Or you can graph cotangent. The three key points here and here. So x value here, y's value here is 1, and here y is 0, here y is equal to -1. So all of them times 1/2. Okay, is 1/2, 0, -1/2. Right, let's see, plot the point. So vertical asymptotes here, and vertical asymptotes here. And in the middle, it is pi over 4. Also, y's value is 0. And pi over 8. So it should be here. And another point should be, let me see, approximately be here. Okay, let's say here. All right. How about y's value? 1/2, 1/2. 0 and -1/2. Okay. Let's connect them with smooth curve. This cotangent. Going up and going down. Okay. Let's see next example. Determine equation for each graph. Okay, first one is very interesting. From this graph, I feel this seems like a tangent because it has the vertical asymptotes from -1/2 pi to 1/2 pi. But also I feel this is cotangent because it is a decreasing function. Maybe we have the horizontal shifting, then we have this graph. So if I follow my first idea, I feel this is tangent. So we say tangent graph is bounced between -1/2 pi and 1/2 pi. That means we have the same period is 1 pi. And also the middle point is 0, 0. That means no horizontal or vertical shifting. So I'm going to have a graph seems like this. So A times, if I say this tangent, and then BX. Some of you say you can put a plus D, but no vertical shifting because the middle point is at 0, 0. So I can erase the D and the B. So we learned P period is equal to, from the graph I can tell is pi, is equal to pi over B. Oh, that means B is equal to 1. Okay, so B is equal to 1. How about A? Do I have vertical stretching? So for the tangent function, let's graph the tangent function. Is an increasing function. And the in the first quarter, the x value is negative pi over 4, y's value is 1, and the middle point, the second quarter, y's value is 0, and third quarter, y's value is positive 1. And we see that in the first quarter, y's value is positive 2, and before we have -1. And then the third quarter, this point, y's value is -2, is opposite, not only opposite, also we stretch vertically. Okay, we can base on the middle point. I'm going up 2 units, that means I'm stretching vertically 2 times. Going down to 2 units, that means I'm stretching vertically. And this is the opposite of my graph. This is the reflection along the x-axis. So I'm going to have my function -2 times tangent x. So I found the graph. And some of you say, I also feel this is cotangent. because the cotangent function is a decreasing function. So this function has another answer, and they are the same. This is cotangent function from 0 to pi. I can tell my graph shift to the left, shift to the, so the center, shift to the left half pi unit. Okay, I can also say this is a cotangent. X minus, plus pi over 2, because I'm moving to the left. So x must be plus pi over 2. And there is no reflection because they all have the going down behavior, going down, going down. So we are going to have a positive number times cotangent. And we learned that this one has been stretched, because from the middle point going up 2 unit, going down 2 unit, but the original one from the middle to here and here is going up 1 and 1 unit. So this question, we're having two solutions. One is negative 2 times tangent x. Second is 2 times cotangent x plus pi over 2. All right, let's see second example. From this image, I can tell this must be cotangent. And I don't know if I have any stretching or shrinking. Let's put a function here. So from 0 to pi over 2, I see these two key information. Vertical asymptotes from 0 to pi over 2. This is one full cycle. That means my period is pi over 2. And then I learned the formula is pi over b. Oh, same top, then same bottom. B is equal to 2. Okay, I solved the b. And what else? So you see the middle point. So the cotangent middle point is at y is equal to 0. Oh, going down 1 unit. That means d is equal to negative 1. And then do we have vertical stretching or shrinking? So based on the middle point, I'm going up 1 unit, going down 1 unit. I can find the first quarter and third quarter. That means no stretching vertically. So in front, also there is no reflecting. So A is equal to 1. So this function is y is equal to cotangent 2x minus 1. All right, let's see number 6. Identify the function. If I gave you an image, can you give me the function? Oh, okay, it gives me the hint. This is cotangent. So A times cotangent x plus d. All right, I'm going to find two vertical asymptotes. So let's find. Obviously, I can tell that the vertical asymptotes is between 0 and pi. Okay, from this image, I can tell that period is pi. And I learned is equal to, so it doesn't, so here, it only has the x, it doesn't have the b. So b is equal to 1. So it's equal to pi over b. Yes, b is equal to 1. I don't have to do this. And second, I want to find a and d. Okay, what is the middle point? So bounce between two vertical asymptotes in the middle must be pi over 2. Okay, my point is here. Middle point. And how about the first quarter and the third quarter? First quarter must be pi over 4. Third quarter must be 3 pi over 4. Where is the point? This point here and this point here. Okay. So this is a cotangent function. Cotangent function mother function middle point is here, y is equal to 0. So the middle point has been shifted down to unit. That means d must be -2. How about stretching? So in the middle, I'm going up 3 unit, going down 3 unit. So this is the y's value of the first quarter, and this is y's value of first quarter. So has been stretched vertically 3 times, and no reflection. So a is equal to 3. Okay, based on this information, I can find my function f of x is equal to 3 times cotangent x plus or minus 2. Let's see next example, number 7. Identify the function. It gave us a hint. F of x is equal to a times cotangent b. No vertical shifting or horizontal shifting. Okay, excuse me. Let's find the two vertical asymptotes. Okay, no battery. Okay, let's see the vertical asymptotes. Okay, obviously I can tell these two lines are my vertical asymptotes. And I can tell center is at y is equal to 0. That means no vertical shifting. And what is the stretching and horizontal stretching and vertical stretching? So let's decide the b first. So b can be found from the period from the 0 to 2, 1 full cycle. So period is 2. So from the graph, I can tell period is 2. And what is the b? So period 2 is equal to pi over b. Okay, so rescue the b. Multiply by b, both sides divided by 2. b is equal to pi over 2. Okay, b is equal to pi over 2. How about a? Okay, what is the first quarter and the third quarter? First quarter is here, should be 0.5. Third quarter must be 1.5. So what is the y's value? Okay, here we can use different color to highlight it. It is the point here and point here. If I have no mistake, yes, I have a mistake because the middle. So the middle going up is here. No, not the middle. The point on the graph has the x equal to 0.5. Y's value is 2. Okay, so from the center going up to unit, going down to unit is my stretching. That means the stretching is 2. So a is equal to 2. Function f of x is equal to 2 times cotangent pi over 2x. Okay, let's see next example. Identify the function f of x is equal to a times cotangent b. Okay, the same method, we can find two vertical asymptotes first. So let's use different color. Vertical asymptotes. I gave you a lot of example about the cotangent. You also have to find the tangent. All right. Can you decide the 1 full cycle? Yes, from 0 to 2. So period is 2. The formula of the period is pi over b. So b is equal to pi over 2. So I found the b. And what is the stretching? Vertical stretching. So first quarter, let's use this color. First quarter, x is 0.5 going up, and the point, but not here. I feel the point is here on the graph. Yes. And how about 1.5? So x is equal to 1.5, y's value is -4. All right, so based on the center, y is equal to 0, going up for unit, going down for unit. So vertical stretching is 4. So a is equal to 4 and no reflection. So f of x is equal to 4 times cotangent pi over 2 times x. Okay.